angles, right?
Mm-hmm.
How much of that do you remember? I guess we're about to find out. Let's do a quick review question. All right, this guy right here. So it says find angle A, B, and C. So where would we start? All right, notice we can start on C, yeah, at angle C, because if you look at it, it looks like this, right?
Mm-hmm.
These two lines are parallel, so that means top left is gonna be top left down here.
Uh-huh.
So what is angle C?
30.
Yes. And now here, 135 and A, we can find what A is. How do we do that?
Well, would it be 45?
It would be, what did you do?
I subtracted 135 from 180.
That's right, so A is gonna be 45. Now finally, what's B? Now notice ABC is a triangle.
Mm-hmm.
So if we know two angles in a triangle, we can find the third side because it always adds up to 180, just like a straight line. So what's B gonna
Okay.
be?
105.
That's right. Now if I asked you, let's say this is D, how would we find D? So you have something like this. So you have this, you have this. So down here is 105. This is 30. What is this gonna be? Now again, notice this line here. We can call this line AB. Line AB is a straight line, yeah?
Mm-hmm.
So what's the angle here of all three angles when you add them together? What do they add up to? 180. Even if there are 10 angles, right? Something like this here, something convoluted. You see all these angles, they would add up to 180. Okay?
Oh, okay.
So this is 30, this is 105. What's angle D?
Is it 45?
It is 45. Okay? So now we know that is 45. We could have actually found that using this rule as well. So this is called a Z rule. If these two lines are parallel, right?
Mm-hmm.
If these two lines are parallel, that means whatever the angle is down here, the angle will be the same up here. So if it's in a Z pattern,
Mm-hmm.
these two angles will be the same. Like, so using this rule, we can find this angle without doing any math. What is this angle?
30.
30, right? Exactly, because this is 30. Another way of looking at that, 30 is because this angle and this angle are opposites, right? You see this up here?
Mm-hmm.
This down here, they're opposites, so opposite angles are equal, so that we can also deduce that it's 30 that way.
Uh-huh.
All right, let's move on. So there's an idea about complementary and supplementary angles. So if you look at a parallelogram, what's a parallelogram? It's just like a four-sided diagram, yeah, in which these two sides are parallel and these two sides are parallel. So in a parallelogram, see the bottom two angles or the top two angles, they are called supplementary. What does supplementary mean? Supplementary means it adds up to 180, just like a straight line. Okay? Another example of supplementary would be like a straight line. Another example would be like a triangle where all the angles add up to 180. If this is 100, what is this gonna be?
100.
No, it has to add up to 180. So
So
these two
80.
sides are, yeah, exactly. These two sides are supplementary, okay? And what would be the angle up there?
It would be 80.
Yeah, that's right. That means this one is 100, okay? So these are called supplementary angles when they add up to 180. Now there's another term, and this is called complementary. So not supplementary, complementary. And this means it adds up to 90. Okay?
Okay.
You see this? These two lines are perpendicular. Perpendicular means that they have a 90-degree angle between them. Okay? So let's say, so same diagram, right? It's 90 degrees. If this is 50, what is this gonna be?
40.
That's right. So you see these two angles are complementary. Okay. Let's look at a triangle. So this right here is called a right-angled triangle because it has a right angle right there. Okay. So this means that's 90 for sure, right? And we know all three angles in a triangle adds up to 90. So what does, 180. Angles in a triangle adds up to 180. So if this is 90, and then we have two other angles, X and Y, what do X and Y add up to? I can make an equation out of this. X plus Y plus 90 is equals to what? These are all three sides in a triangle.
So 180.
180, right? So if you want to just solve for X plus Y, what do we need to do?
You just you would just like subtract it instead of adding.
Subtract what? Yeah, you would subtract something. You'd subtract the plus 90, okay?
Okay.
So 180 minus 90, you'd subtract 90 from both sides. So you get X plus Y, this disappears, equals 180 minus 90, which is 90. So what does this mean? This means in a right angle triangle, one angle is always gonna be 90, and the other two are gonna be complementary.
Okay.
Okay, and this is called a right angle triangle. There's a bunch of different types of triangles, like I'll just show it to you. This is called an equilateral triangle, where all three sides are equal. Equilateral triangle. Okay, all three sides are equal length, and this also means that they're all 60, 60, 60. Equal lengths, equal angles. The next type is called isosceles. And this means these two sides are equal, okay? And these two angles are equal down here. Actually, if it's 60, 60, then that's not gonna work. Let's make that 50, 50. 50, 50, and that means this angle up there is 80, and this side is maybe 5. See, only two sides are equal? This is called an isosceles triangle. And then finally, you can have something like this, where none of the sides are equal. You can have 3, 4, 5, and then angle, you can have 30, 40, and then 110, something like this. So if none of the sides are equal, none of the angles are equal, that's called a scalene triangle. Okay?
Okay.
And then the one that we're concerned with going into the next part of the unit is the right angle triangle, where it has a right angle somewhere. Well, it's always gonna be right there between the two perpendicular sides. And in a right angle triangle, okay, there exists three sides. We can say this side is A, we can say this side is B, we can say this side is C. You see side C is opposite of this 90-degree sine, right? So what does this mean? This means in a right angle triangle, C is called the hypotenuse. So there's a term for what this side is called. It's called a hypotenuse, and it is always the longest side.
Okay.
So if this is 4, this is 3, this is 4, then this must be 5. Okay, it must be longer than the other two sides. And again, the right angle triangle is very powerful because there's a theorem here. Again, this is A, this is B, this is C. The theorem is called Pythagoras theorem. Some guy, mathematician called Pythagoras, came up with this. And it's like a formula. It's very powerful. What does it say? It says this. In a right angle triangle, only in a right angle triangle. In a right angle triangle, A squared plus B squared equals C squared. Now, what does that mean? Let's look at a quick example. If A is 3, if B is 4, what would C be?
Would it be 12?
It would not be 12. Oh, I know what you did. Or do I? I don't know, actually. How did you get 12?
Wait, am I supposed to like...
So here, we're trying to solve for C, right? We don't know what this side is, yeah? So let's plug what A is. A is 3. So you get 3 squared, okay? Not 3 times, so this is 3 squared plus B is 4. B squared equals C squared. What is 3 squared plus 4 squared? Oh, actually, what is 3 squared?
3 times 3.
Yeah, that's a 9, okay? Plus, what's 4 squared?
16.
Good, equals C. What is 9 plus 16? That's a 25. So you have 25 equals C squared, okay? So what is C gonna be? How do you get it to the squared? We're trying to solve for C, we have a C squared.
Would you just put 5 squared?
So C, to solve for C, okay? You need to square root both sides. You see how we subtracted in the question before? You need to do the opposite, okay? So if it's C squared, to get rid of this squared, you have to square root both sides. That's the opposite of a squared. What's the square root of 25?
5.
5, there you go, C is 5. Okay?
Oh, okay.
A squared plus B squared equals C squared. Let me see if I can find you something. So you see this? This is side C, okay? Can I zoom in on this? Yeah, I can. See the longest side? That's opposite to right angle side C. And this is a square, right? They're all 3 squares. You see this water is gonna be equals to this water plus this water. The area of this is equals to the area of B plus the area of C.
Oh, okay.
A squared plus B squared equals C squared, okay? All right, let's try and attack this question. And the math is easy. It's always the word problems where you have to convert the thingy into math. That's kind of hard. All right, let's try and make a rough sketch out here. A roofer has a ladder that's 12 meters long, and he needs to tar a flat roof that is 10 meters above the ground. All right, let's draw our triangle. We know this is going to be a triangle question because maybe that ladder is way too steep. So let's say this is the building, okay?
Mm-hmm.
There's a window, and here's Timmy watching the TV. Not really significant. How tall is the building? It's 10 meters, yeah?
Uh-huh.
So we have a side length, 10 meters. And that's the building. Now say this is the ladder, okay? It's been propped up like this. How big is the ladder?
Wait, what's the distance at the bottom?
We don't know yet. But we do know the length of the ladder. It says right there, a roofer has a ladder that is 12 meters long. You see this is 12.
Mm-hmm.
What else do we know? So we know he needs to tar a roof that's 10 meters above the ground. So we know the building is 10 meters.
So is the bottom 2 meters?
Well, we need to find out, all right? Let's see what else we need to, because this diagram is not complete. It says that the top of the ladder must extend at least 1 meters above the top of the wall. So what does this mean? This means that if we draw another small triangle up there, yeah?
Mm-hmm.
This height must be 1 meters. It must be 1 meter above this top of the building, okay?
Okay.
Also, the foot of the ladder must be at least 1 meters from the base of the wall for every 3 meters of ladder. So that means it's 3 times as long. Okay, the ladder is going to be 3 times as long. But we're not concerned with that just yet. Let's find what the bottom side is, okay?
Okay.
So if this is A, and again, hypotenuse is always C, the bottom side is going to be B. So how do we solve for what B is? So again, we're going to use the Pythagoras theorem, all right? What we can do is we can combine these two triangles to get a better B value. So this ladder needs to be 1 meters above the top of the building. So we can say the ladder needs to go all the way 11 meters high, okay?
Mm-hmm.
And the ladder is 12 meters long, okay?
Uh-huh.
We're trying to find B. This is A, this is C. Pythagoras theorem tells us A squared plus B squared equals C squared. So in this equation, how do we solve for B?
Is B 4?
How do you do that? Let's isolate this equation. B is probably not going to be 4. So we're trying to solve for B, right? So it will subtract A squared from both sides, okay? Again, this is an equation. We're trying to solve for B. So B squared is equals to C squared minus A squared, okay?
Okay.
Now, how do we solve for B? We don't want B squared, we just want B. So what do we do on both sides?
You just subtract 12 and 11.
So yeah, you would do that, but you need to square them first. Here, don't worry about the numbers. We're just trying to solve for what B is. What if there was no numbers? How do we isolate for B? You see the squared? We need to get rid of the squared. What do we do on both sides? We square root on both sides.
Oh, okay.
Okay, there we go. That's our formula to find b every single time. But you don't need to remember this. You can just work your way from there, right? Same thing with a. If a was missing, then a would be the square root of c squared minus b squared. If c is missing, using the same thing, we need to first subtract b squared. So if c is missing, then well, c is missing, then we just square root both sides from the very first step like that.
Okay.
Now let's plug in the values. C is 12, right? So it's 12 squared minus a is 11 squared. So why don't you try plugging this in the calculator? What do you get?
Um,
So here's how you do it, okay? If you're gonna plug it in the calculator, you need to open a square root and then do a bracket, and then you do 12 squared minus 11 squared, close bracket, equals 2. If you're trying to do it on the calculator in one step. Otherwise, you can just do 12 squared, which is 144, minus 11 squared, which is 121, and that is the square root of 23.
oh, okay.
It's gonna be 4 point something. 4.8 or 4.9, something like that.
It's 4.8.
Yeah, there we go. Okay.
Mm-hmm.
Let's try doing another one.
Let's just go do this before I lose my nerve. Oh, right. We're stronger than you. Well, at least I am. And there's 2 of us. 3
So here,
Let's
what are we given? So there's 2 guys, Eric and Calvin, right?
Mm-hmm.
Well, let's say this is Eric, and let's say this is Calvin. And we know they are 60 meters apart. Yeah?
Mm-hmm.
And it says Eric is flying a kite. Calvin is directly under the kite. Let's say the kite is right there. Calvin is directly underneath him, and Eric is flying it. So a triangle would look something like that.
Mm-hmm.
Okay?
Yep.
And it says the string is 100 meters long. So is this the string, EK, or is KC the string?
EK is the string.
Exactly, EK is the string. So that's 100 meters, and we're trying to find this. This is side A, right? A equals what? So Pythagoras theorem tells us a squared plus b squared equals c squared. So how do we solve for a?
B squared minus c squared, and then square it, like both sides.
So you want to subtract b squared on both sides, right?
Mm-hmm.
The c is always the hypotenuse, b is always the bottom one. B for base, you can think of it that way. So then what would a be equals to? A is gonna be square root of c squared minus b squared. Okay?
Okay.
Do you understand this math here? What we did?
Mm-hmm.
So now we just plug things in. Why don't you plug in the numbers and tell me what you get? The answer is, oh, well, I know the answer. Try plugging the numbers in and tell me what you get, because using the calculator is also a skill.
Do I have to like square 160?
Yes, you do.
It's 80.
Yeah, good. There we go. This height, the kite is 80 meters above Kelvin. Yeah?
Mm-hmm.
That's right. What about here? Which side is missing, A, B, or C?
C.
C is missing. Right? So what's C? Again, it's a one-step calculator problem. C squared equals A squared plus B squared. So C is equals to A squared plus B squared in a square root.
Is it 10?
It is 10. There we go. By the way, did your school start? Are you taking maths?
Yes.
How's that going?
It's going okay.
What are you doing in school?
Integers.
Any issues with that?
No.
Or this one, it says a right triangle has two sides that are 7 centimeters each. So let's first draw a right triangle. Okay, right triangle just means like a right angle triangle.
Mm-hmm.
So again, we have A, B, and C. So which two sides are 7?
A and B.
Yeah, A and B is 7. And it says label the complementary angles. So which angles are complementary?
Is it A and B?
So where are the angles? This and this? Are these two complementary?
No.
Yes, they are. Because we know this is 90, right? An angle in a triangle, the angles always adds up to 180. So A plus B, whatever they are, we don't care about what they are, but they will add up to 90. Here, look at this. A plus B plus 90 is 180. Subtract 90 on both sides. So A plus B, this angle plus this angle is 90 degrees. So they are complementary.
Okay.
Okay. Can there be more than one triangle that fits this description?
Yes.
What would another triangle look like? So yeah, there's like an infinite number of them, okay? So you see this one looks like this. What we can do is we can just turn it upside down. And we can say this is 7, this is 7. And again, these two angles are gonna be complementary. Or we can rotate it the other direction. This is 7, this is 7, yeah?
Mm-hmm.
Or yeah, exactly. There's like an infinite number. Or we can like tilt it just like that. So there's a lot of triangles that you can make just by having two sides, okay?
Uh-huh.
Part C, can one of the 7 centimeter sides be the hypotenuse? Why or why not?
It can't be.
It can? Yes?
It can't.
It can't? Why?
Because like the hypotenuse has to equal the other both sides.
Yeah. So hypotenuse has to be the longest side in a triangle.
Mm-hmm.
Okay, it has to be the longest. So if this is 7, this cannot be 7. It has to be longer than that. Okay.
Mm-hmm.
Actually, here's a question for you. Let's say this is your home, all right? Home sweet home. Whatever. And then this is your school, okay?
Mm-hmm.
You have 2 ways to get home. You can either go this way and then go this way. Okay, like that.
Uh-huh.
Or you can go this way. The first one, we will call this route A, okay? So going this way
Mm-hmm.
is route A, and the other one is route B. Which one do you take? Well, which one is quicker? Which one is more efficient? Because no one wants to go home late.
Well, I'm guessing B would be quicker, but like if the 2 sides, like the green ones, if like they equal B, then it won't really matter.
So the thing with Pythagoras theorem is, right, it says a squared plus b squared equals c squared, yeah?
Mm-hmm.
So this means that c is bigger than both a and c is bigger than b as well, okay? Individually, c is bigger, but c is not bigger than a plus b. Okay, this is not right. C is not bigger than a plus b. C is smaller than a plus b. By the way, you see this sign? When I say
Mm-hmm.
something like this, so this is the greater than sign, okay? And how do you remember this? Think of this sign as the mouth of an alligator, right? That's a pretty visual way of remembering it. This is the mouth of an alligator, and this is always
Mm-hmm.
gonna eat the bigger fish.
Uh-huh.
So that's the greater than sign.
Okay.
So C is greater than A, C is greater than B, that's fine, but C is not greater than A plus B. So if A is 3, or that would be A is 3, let's say B is 4, right?
Mm-hmm.
Using Pythagoras theorem, what is C gonna be?
It'll be will it be a decimal number?
No, it won't. So we're looking for what? This is not side B, that is just root B. This is side C, right? The hypotenuse.
Mm-hmm.
So solve for that. So C is equals to the square root of A squared plus B squared.
So 6 plus 16.
Where'd you get 6?
Oh, it's 9 plus 16. Okay.
And then you square root that.
So 5.
5, right? So side C is 5. So if you take route A, you'll end up walking like 7 kilometers.
Mm-hmm.
If you take route B, you end up only taking walking 5 kilometers. So there you go. Take route B.
Okay.
This side is bigger than this side or this side individually, but when you combine them, it's not bigger. Okay?
Mm-hmm.
And you can use this in real life. Like let's say there's a parking lot, right? There's a huge parking lot here, and you want to get to this store. You're right here, yeah?
Mm-hmm.
Just walk across it. That'll be the fastest route. Okay? Or even in like a store, even in like a store itself, you want to get there. There's 2 ways to get there. You want to take the diagonal way. That'll be the quickest.
Uh-huh.
All right, we don't really need the word problem. They've already drawn the sketch for us. So this is the triangle, okay? We're trying to find the distance down here. M refers the horizontal distance all the way from here to here. Any ideas how we would proceed here? Again, we're just going to be using the Pythagoras theorem, what we've learned.
Is there like a reason there's 1,000 in the middle, like the height?
Yeah, there's a reason, because you're going to use the height. In fact, this is one of those questions where you have to split it apart into two different triangles. You need the distance, all this distance, right? What you need to do is first find this distance from this triangle. From the triangle on the right, you see there's two triangles? And then find this distance from the triangle on the left. Okay?
And then add it.
Yeah, exactly. And then you add them and then you'd get whatever the total distance is. Let's look at the triangle on the right. So which side is this one? 1,000, A, B, or C?
It's A or B.
Yeah, exactly. It's A or B. So this has to be the C, right? And we're looking for B. So how do we find B? A squared plus B squared equals C squared. Step one, subtract A squared from both sides. So you get B squared equals C squared minus A squared, right? And then you square root both sides. So there you go. That will always give you the B. Now it's just a matter of plugging things in the calculator. Plug it in and tell me what you get. So you just do this, right? C is 2236 squared. Okay, you have to square it. And A is 1,000. So you plug that in the calculator, what do you get? No? Which calculator are you using? Okay, you can just do this square root symbol first. And then after you're done that, you open a bracket, you do 2236 power 2. That's the symbol for power 2.
Okay.
Minus 1,000 power 2 close bracket equals 2. You didn't get it? What is this telling you?
Well, I got 199.
Yeah, that's right.
909.
Yeah.
0.9, sorry.
So 1999.99 or something like that. 92. Now we're gonna do the exact same thing on the other side. The formula is exactly the same because we have A, but on this side, the hypotenuse changes. That's 1414, okay?
Okay.
See here? So this is gonna be, or this is gonna be, yeah, 1414. And again, that'll give us what B is, the base. Try this now. So 1414 squared minus 1000 squared, the square root of that.
It's 999.7.
Yeah. Now we just add this with this, and that's the final answer.
It's 2999.62.
Yeah, there we go. Okay.
Mm-hmm.
Was it hard plugging in the calculator?
No, not anymore.
Okay, here, you're gonna do another one. This is 10, this is 30. What is side C? Again, notice, right? We're looking for C. So C is equals to the square root of A squared plus B squared.
So it's like 28.3.
No, cannot be 28.3 because, again, you need to add them up, not subtract them. Hypotenuse has to be longer, right, than both the sides.
Okay.
So it cannot be 28. It has to be greater than 30.
Well, I ended up with 1,000. So do I square root it?
Yes.
It's 31.6.
Yeah, there we go. Okay, now I'm not gonna give you this anymore. I'm gonna come up with something like that. Let's say this is 40, this is 10. What is this? You just have to take into account which side is missing. If the C is missing, then you add, right?
Mm-hmm.
If either A or B is missing, then you subtract.
Is it 38.7?
Yeah, there we go. Okay.
Mm-hmm.
And once you know how to plug that in the calculator, it becomes pretty simple. So what do we have? We have an equilateral triangle. What does that mean? That means all three sides are the same lengths, okay?
Mm-hmm.
And then it also says that it's the perpendicular bisector of its base. That means you see this dotted line?
Mm-hmm.
It's cutting the base in half, okay? So if we know each side is 6 centimeters long, how much are these two segments? What's the length of these two segments from here to here and from here to here? This dotted line is cutting the base in half.
Oh, so like each side would be 3.
Yeah. Okay, so this up until here is going to be 3. And same thing on the other side. Yeah?
Mm-hmm.
So we're looking for the height. So are we looking for A, B, or C? We have two sides of a triangle, right? Just look at the right angle triangle.
So we're looking for A.
Yeah, exactly. So find it for me. Do we add or subtract?
Subtract.
Good.
Um, 5.2.
That's right. So that's the height of this equilateral triangle. Okay, easy. This one looks really complicated. All right. So all the information is basically already in the diagram, okay?
Mm-hmm.
It says the distance from, say here, right, to here, the total distance between these two cities, Toronto and Winnipeg, that's where you are, I think, right?
Mm-hmm.
So there it's 1,500 kilometers. Question A is asking you, how much distance do the climb and the descent add to the flight? So now what does that mean? That means this.
How much the C's
Yeah.
equal?
So if the total distance is 1,500, right?
Mm-hmm.
This is 300, this is 200. What's the distance from here to here? Okay, well, think of it this way. If this is 300, if this is 200, okay? The entire thing is 1,500. So what's the distance between here and here? So this is 300, this is 200. It's 1,000, right? Because 1,000 plus 300 plus 200 is 1,500. So if the entire thing is 1,500, if this is 200, this is 300, this middle must be 1,000, or 1,500 minus 200 minus 300.
Mm-hmm.
So it's flying horizontally for 1,000 meters. Cool?
Yep.
Now we just need to add what the hypotenuse is on this triangle and on this triangle to get the total distance it flew. So let's look at the right triangle, the triangle here. So the height of that is 10,000. The base of that is 200. What is going to be its hypotenuse? Again, it's a calculator problem. Just plug it in. We're looking for side C, right? Hypotenuse is always side C. Okay, this is A is 10,000. This is B. We're looking for C, yeah? C is the square root of a squared plus b squared. So you're just doing the square root of 10,000 squared plus 200 squared. On a calculator, you just do square root, bracket open, 10,000 squared plus 200 squared, bracket close. No, you're having trouble with the big numbers? That's what it is?
Mm-hmm.
You're using the big calculator, not like a scientific calculator? Right?
It is a scientific calculator.
All right, so here, just do what I do, okay? Press the square root button,
Mm-hmm.
open a bracket, type in
Okay.
10,000, so that's 1000. The 4 zeros in total after the 1, okay? And do you see
Okay.
this symbol here, power 2 or squared or whatever on your
Uh-huh.
calculator? So type that, 10,000 squared plus 200 squared, bracket close, equals 2.
Okay.
What does that give you?
Wait, did I have to add or subtract?
You tell me, we're looking for C. When we're looking for C, you add. When we're looking for either A or B, you subtract. No, still struggling?
Mm-hmm.
What's the calculator called? Did you press the equals to sign? It didn't give you anything?
It had like error on it or something.
Is the name of the calculator on the top? What is it called?
No, it's not at the top of it.
Oh, here, look at this. This is what you do, okay? Square root, yeah?
Mm-hmm.
Bracket open, 10,000, so 1, 0, 0, 0, 0, yeah? Do you have this button, A squared, or what do you have?
It's the a squared one.
AC, 10,000 squared plus 200 squared, bracket close,
Mm-hmm.
enter. And there we go. Try that. If it's still giving you an error, I'm not sure what's going on. Maybe the squared button is something else. You can tell me the model number, maybe I can figure it out. Is it still giving you error?
Mm-hmm.
I'm not sure what is happening. It doesn't say like sharp or eel something anywhere on the calculator, like or on the screen.
No.
Okay, well, how about we try something else? We just try this, okay? 10,000, okay? 10,000 squared plus 200 squared. Let's try that. Is that giving you anything? Does that give you this?
It gave me like 100.009.
Did you type 10,000 squared
Mm-hmm.
plus 200 squared? It only gave you 100.
Like it gave me a point number.
I'm not sure what's going on with your calculator. Anyways, I'm just gonna use a computer calculator and this is what I got, okay? I'm just gonna round this up to 10,002. So C is 10,002. Yeah?
Okay.
Now same thing here. What's the height of this triangle? The triangle on the left, what's the height?
10,000.
Yeah, exactly, it's 10,000. So this is 10,002 and this is 10,000. And again, we're trying to find the hypotenuse, right?
Mm-hmm.
So look at this. Square root of 10,000 squared plus, again, C value at 300 squared, bracket close, enter. And that's 10,004.5. I'm just gonna round that up a little bit. 10,004.5, yeah?
Mm-hmm.
So what's the total distance traveled by the airplane? So the total distance the plane travels is this line, right?
Mm-hmm.
Plus this line, plus this line. No? That's 10,002, yeah?
Mm-hmm.
Plus 1,000 plus 10,004.5. Yeah?
Mm-hmm.
That's 20,006.5. So that's gonna be 21,006.5 kilometers.
Okay.
Okay, see the original distance was only 1,500.
Mm-hmm.
So how much did that climb add? You just subtract 1,500 and that'll be the excess distance that it had to travel. 0.5 minus 1,500, and that's gonna be 19506.5 kilometers. This is the excess distance, yeah?
Okay.
Let's look at part B. The airplane averages a speed of 600 kilometers per hour. Do climbing and descending 10,000 meters add hours, minutes, or seconds to the flight? So before, right, before the plane would take, if it did not have to go up and down, if it just went on the road, it'll, well, how long would it take? 1,500 kilometers divided by the speed, 1,500 divided by 600, that's 2.5 hours, yeah? This is if it just went on the road at 600 kilometers per hour. But in the sky, it has to travel 21,006 kilometers, right?
Mm-hmm.
Divided by 600. So 21,000, 6.5 divided by 600. So that takes, all right, 35.01 hours.
Okay.
So did it add minutes or hours? It added a lot of hours.
Mm-hmm.
Okay, you understand this question?
Uh-huh.
Here, one last thing before I let you go. Type this in your calculator. 9 squared plus 10 squared. Square root of that. If it doesn't work, then maybe you can ask your mom, like, what's going on with what's bugging out. Square root of 9 squared plus 10 squared. What is that gonna be? So that's the hypotenuse of a triangle with side A and base B.
It's 13.45.
So how did you do that? And it didn't work before. Let's try this again. 10,000 squared, that's right, plus 200 squared. Do the exact same thing that you just did, except 9 is 10,000 and 10 is 200. Oh, maybe don't put a comma, by the way. In 10,000, just write 1 with 4 zeros. No need to put like decimal, comma, nothing.
Oh, okay.
Do you still get an error?
It left me with like
What did it give?
1001 point something.
Yeah, I'm not sure what's happening with big numbers. Maybe you're in scientific mode. I'm not sure. We'll pick it up tomorrow. Maybe we'll try and fix it. All right, take care now.
Bye.
Bye-bye.